Very good morning and welcome to the little presentation on HTML5. So we're going to cover some HTML5 top 10 threats and why they are stealth and silent. You will see during the presentation. Before getting into a brief introduction of mine, I'm a founder of a company called Blue Solutions, and we provide various different services focused on application security only. So we do consulting, trainings, on-demand scanning, source code audits, and so on. Past work with NetSquare, Foundstone, Chase, IBM, and so on. My primary interest is web security research. So try to come up with scanning tools, utilities, coming up with the new concepts, papers, and so on. So these are some of the work done by me over the last 10 years, some articles, tools, advisories, papers, and so on. And these are some of the books written by me, web hacking, hacking web services, and Web 2.0 security. I do blogs, so you can follow me on sridhar.blogspot.com. Recently did a lot of blogging on HTML5 and course and so on. So some of the part which we are going to cover during the presentation and so on. Okay, so agenda for today, we'll start briefly on HTML5 and security. We'll look at evolution, threat model, and browser architecture to fit HTML5 into current context. And then there are 10 threats which I've identified. There are it can be a top 10 or depending on your perception, you can put it there, put it in the order. But these are the 10 threats, which starts with CORS attack and CSRF, click checking, core checking, XSS, web storage, SQLI, with the blind enumeration, web messaging, DOM-based XSS, HTML5, and messaging system, third-party offline HTML widgets, WebSocket, and protocol, and then we'll conclude. Okay, so first, HTML5 security. HTML5 pretty much came into picture 2008, 2009 onwards. There were around ENISA studied around 13 HTML5 specs, and they identified 51 security weaknesses or threats. Definitely, if you read these papers, some of them look like more theoretical, but then some of them are really practical ones as well. So HTML5 is reshaping the browser architecture, and HTML5 is pretty much bringing new opportunities for attacks for cyber criminals or attack threat agents and so on. And web developers are integrating these HTML5 libraries, and it has a lot of security issues around. So these are some of the surface which HTML5 is essentially opening up the attack surface. If we quickly look at the evolution, how HTML5 came into picture, pretty much till 2005, if you look at HTML was pretty lame. So there was nothing much power in HTML, but as soon as 2005, when the whole RIA space came into picture, it has come up with the AJAX, XHR, and DOM specs, which were completely re-engineered. So at that point onwards, pretty much HTML4 plus has started to pick up, and by 2009, we have a standard ready for HTML5, which can compete with Adobe Flash and Flax stack or a Silverlight stack as such. So HTML5 is essentially nothing but the HTML, CSS, and JS, which is powered by document object model and XHR and WebSockets and so on. So we'll look at that. So quickly look at the HTML5 dynamics, what have happened in last 3 years or 5 years. If you look at, we usually had a presentation layer which runs your client-side stuff, and then you have a business and data access layer which runs on the server side. That space has been shrinking. So now what we have is when you go to the website, you download, say, RIA component, Silverlight, Flash, or HTML5 page. It has some kind of a business layer and a data access layer within the components which you have loaded. So one of the key change which we are seeing in the current generation application which comes for the review is, it's not the client side component is not just the presentation layer. It has some business functionalities, business logic involved. It has some data access layer and so on, which again open up, as you can imagine, from the attack perspective, it opens up some surface, because now you have access to the business layer to manipulate the business layer as such. Now in that stack, what we have is is a four key technology stacks evolving. One is a Flash by Adobe, Flash, AMF, Flash storage, and so on. Second is Silverlight, WCF, .NET, and so on. And then HTML5, web storage, WebSocket, WebSQL, XHR, and that particular stack. And pretty much HTML5 is bubbling up, and all these two different stacks, which is a Flax and a Silverlight, is pretty much dying. So maybe down the line, 2 or 3 years, you will not see updates coming from a Flash and a Silverlight, and HTML5 is bound to dominate. On top of it, you have the whole mobile stack running iPhone, iPad, tablets, Android, and so on, which again using HTML5. So when you load, say, native iPhone app and you're using a web view, or you load a native Android app and you are loading a web view, you are nothing but you are loading the HTML5 components as such. So this is the kind of HTML5 dynamics at this point. So HTML5 in nutshell, there are various different standards in the kitchen, so they're cooking up. Some of them are in working drafts, some of them in last call, some of them are already recommended, and then you have WebSocket, HTML, messaging, web messaging, and so on. So you're on the right hand side, you can see over here a lot of different new components added, be it a canvas and video, drag and drop, offline browsing, WebSQL, web workers, which is a threads inside your browser, and so on. So pretty much what we are looking at today is HTML5 is just the warming up. It's like just 3 or 4 specs which we are discussing right now. There are like another 15 coming up. So you can imagine the kind of HTML5 things which is boiling up in your browser. So what is a modern browser architecture would look like? So you have 4 distinct layers, and every layer has a new HTML5 has a significant impact on these layers. So the first one is definitely a core policy, where you have a sandbox policy, which is a new in HTML5, which is kicked in, and then you have a CORS there. CORS is a cross-origin resource sharing policy, which is again a top-up of SOP, that is a same origin policy. So that's the one area. The second is network access. So we always had a browser native network services plug in through a sockets, but there are 2 new sockets which are now in. One is a web socket, and then second is XHR level 2 calls. So pretty much that's the layer where again HTML5 has significant impact. On a process and logic side, DOM is powered by DOM 3 specs. You have a JavaScript. Interestingly, you have a parsers and threads within your browser, so you can use a web workers and spin off the threads inside your browser space. And to support the whole business logic, now you have 3 different components. One is a WebSQL, by which you can write a local database which runs in your browser. You have a storage, like a global variables, which will remain throughout the scope of your session. And then you have a cache, which you can cache the pages in your browser and don't have to make a HTTP call to the server. And on top of it, on the presentation stack, pretty much what you have is HTML5, CSS, API, and messaging. So these is essentially an app layer stack. Now, what are the threats which we are looking at? One is definitely a CORS and SOP, which allows you to do any data transfer. So essentially, with the CORS and with the XHR, now you can open up a tunnel to any server and say, okay, here is my JSON, or you can open up a tunnel and say, here is my XML, and so on. So there are some origin issues which can be bypassed. Web messaging, cross-domain calls, web workers, domain call, and logic issues, local storage, information leakage, and identity. Web SQL, UI redressing, attack vectors, DOM, and several issues. And then you have bunch of different APIs which are exposed in HTML5, be it a geolocation, sockets, drag and drop, and so on. So if you look at a simple application, which is of HTML5 over here, so you can see over here we have evolution. We started with a 1.0, then we have XML driven application, then a Flash, JSON came, Silverlight, a Flax driven application which talks to the backend with AMF, and then now we are in HTML5. Now, here is a very simple tool which is very interesting developer tool, which comes with Chrome, where there is a resource tab where you can see what application is writing, and all these are HTML5 stuff, say a database or local storage and so on. So now this is the application. We just go to the HTML5 app web store over here. As you can see, as soon as we logged in or we just visit the page, a local storage web SQL is created. So when you go to the page, it has dumped the database from the server to the client, and you can see SQLite, where a Chrome and a Firefox would have that particular small database sitting in their browser space where it is loaded. Now we go and say try to log into the page. You say okay. You can see a local storage here. There is nothing right now, but as soon as you log in and go to the local storage, you can see the hash. So essentially, once you logged in, a session has been created and a token has been passed to the local storage. So now whenever you go with that particular session token, you will serve with those pages. So that's a local storage has been injected with HTML5. And then there are pretty different features. Say for example, a lot of widgets, which is using web messaging, which is HTML5 component, or you have a messaging widgets, which is using a web worker over here. And then you can create some mashups with HTML5. So this is a typical HTML5, or I would say a next generation application would look like. And these are the attacks from A1 to A10 as I discussed. So we'll start with one after another. The first one is coarse attacks and CSRF, which is again a big chunk of attack vectors would be focusing on coarse and cross-origin resource sharing as such. Now, these attack vectors are focusing on coarse and XHR level 2. So this is a combination of attack vectors which would be focusing on. So before HTML5, we had a XHR level 1. Now XHR level 1 was used to follow SOP. So say for example, if you load your JavaScript from yahoo.com, the XHR script, then XHR can make a calls to just the yahoo.com. It can't make a call to a google.com or any other domain. Now with HTML5, that restriction has gone. So pretty much it allows you to do cross-origin calls, but the coarse, which defines the calls identity. So coarse is a cross-origin resource sharing, and it needs to follow something called a pre-flight call. So in a pre-flight call, on the server side dictates whether I have to serve this guy with which method and so on. So that's where the coarse comes into picture, and everything is governed by some added extra headers. So these are the HTTP headers which are added in your browsers. So browser will make an origin call. So like a referrer, we have an origin which is going in HTTP call, which says that from where I'm coming, and based on that, server will take a decision. Now access control are defined by methods and headers by pre-flight calls. So essentially before serving the content, your browser will send an option method and try to dig through what kind of a policy which you have set on the course. And then server will come up with these responses which will have the information which browser needs. So still threats, CSRF++, which is powered by XHR level 2, because now what we have is a very silent one-way communication channel which is already established. Because what you have is anyway, when you initiate the transaction or initiate the XHR call, a request has been sent from your browser to the server. Now whether the course is allowing or not, it defines whether the page has to be loaded in the browser or not, but you have a one-way HTTP request generated. Interestingly, from the XHR, you can craft any stream. So you can craft XML, you can craft JSON, you can craft AMF, whatever you want to craft, pretty much you can craft and send to the server. Course pre-flight bypass. It's with the specs, what they have is, if you have a certain content type, then a pre-flight check will not be there. So anyway, you will get a full one-way connection. You can do internal network scanning and tunneling. Interestingly, if your servers inside your internal network is allowing origin to star, so it serve a content coming from any origin, then actually you can write a little HTML crawler which find the server which is serving to any content, and then through XHR you can grab all the content and post wherever you want to post it. You can create a stealth browser shell as well by allowing setting the origin to the star. Now interestingly, with the XHR there is something called with credentials flag. So if you set it to true, your cookie is also going to get replay. So again, you get a power of a session hijacking over there, where you say, okay, make XHR call, put a session cookie on, so then that's interestingly allow that. And then you have a business functionality abuse, like upload and a stream. So first is CSRF with XHR and HTML5. So this is a typical scenario where you establish your session with a web store and you say, okay, this is my login credential. You get a session cookie, browser using XHR JavaScript, and then making a JSON call and say, okay, I want to put a buy request. So it'll put a JSON request and you will get a success back. Now, your session is still live, and you visit an attacker page. So attacker is going to send you a little XHR script, which will have a content type set in such a way that it will avoid pre-flight call. And then on top of it, you have a with credentials set to true, so your cookie will actually replay. So here is a snippet of the code where you are setting the header content type to text plain. So when you have a text plain, there won't be any pre-flight, no option negotiation required there. And then you are setting your with credential equal to true, so your cookie will replay. And then you can see over here, this is where you are passing the nice JSON stream. So you say, okay, this JSON can be XML or any stream which you want to pass on, you can pass on. If you want to create this kind of a call by a native browser call, you won't be able to make it because you have a form where you inject, then you have to hide your equal to sign and so on. So this is a way that actually you are loading this page from yahoo.com or any other domain and then making XHR call to the cross domain. So pretty much that particular script will get loaded, will initiate the connection, the cookie will replay. So what happened is, with victim's consent or a notice, without victim's content or consent or a notice, still HTTP request get generated from your browser, and silently whatever business functionality is bound to get exploited. So let me show you a little demo here. Okay, so over here you have a JSON page, and you have a kind of a buy request. So when you actually put that request, you will see this kind of a JSON services which is invoked. Now you can see over here we are on a 100.21 domain or 100.21 IP address, which can be a separate domain. And you can see when I click a legitimate user, when we click, we get the cookie get replayed, and we have this nice JSON stream going in. Okay, so now we move to a separate domain. So as you can see, JSON request goes, JSON response we get out from the server. Now here is a catch. Definitely, if a library on the server side or a developer is checking the content type before serving, it say, okay, I'm expecting JSON, but you are sending you a text plain as a content type. That check is there, then pretty much XHR will kick in, but the response will be blocked on the server. But many of these libraries are not checking this, or developers are not checking this. They are interested in having a nice JSON. That's it. If a JSON is good, they will go ahead and process it. So now we go to a different page. Now this Go is not required, this is just for the demo, but we are on now 100.6, which is a completely separate domain which we are on. And we just look at the source here. So on the source, what we have done is we just posted 100.21 JSON JService. We have posted the buy request for this product number 2. And as you can see, we have a content type to text plain, and then credential equal to true. Okay, so with that, okay, we put that and we click on Go. For that, I'll just show you the HTTP request here. So this is just the Burp proxy, which is showing the actual HTTP calls. I click on 100.6 and a go function, and as you can see on 100.21, which is a cross-domain call from a 6, you are on a 6, but the 21 where a nice JSON has been posted. The only catch is, as I said, is a text plane. So we have posted this, and this is a clear case of CSRF and the silent exploitation. So this is HTTP request generated. We got a response back. Now there is something implementation which is a part of a browser which take the HTTP response will not load the response to the browser. That's how the course is defined. Similarly, this CSRF, now since we have a stream, we can stream anything to the XHR. Interestingly, we can stream in the file upload. So we can say, okay, dynamically we create a file, and if there is an upload functionality on the server, we can stream or force a CSRF upload. So say for example, you have a page where you have a page where you have a profile, and a profile has a photograph, for example, your headshot, and you visit to a page, and your photograph will get changed because someone will actually put a dummy image and upload onto your functionality, which is upload functionality, which is used by that particular application, is not looking for CSRF token or so on. That kind of a not a so serious mischief, but for example, you have a critical business functionality. Say for example, someone is uploading invoices, someone is uploading your orders or so on, and now that functionality, if not checking for the CSRF, then you have issue. So say for example, over here we have a page which is doing a upload of a bulk orders. You want to upload a bulk order, so we have a nice formatted file, be it XLS or be it a comma separated CVS and so on. So we have that file, and we upload the file when we want to do a legitimate bulk order process. So you have upload form. When you click on upload form, you will have a nice multi-part request which get generated and posted on the server. Now you visit to the attacker's page, and it'll send you the XHR request, and that XHR will actually post a file which is created on the fly to your upload functionality. So without your consent or a notice, you have uploaded a file. You have placed an order or a file or an order on the server. So this is like HTTP upload via CSRF. That's something which you can actually do. So let me show a little demo here. Okay, so you have a login. We log in onto this little functionality. We go to the order status, and then we say, for example, we want to place an order. So we go to the new order, and it has a bulk order here. So we can say, okay, I want to post a bulk order. And on the bulk order, we say, okay, choose a file. So we choose a one file over here. Before that, okay, so this is a file, and we click on say upload. So file has been uploaded, processing for uploading over here. We are on 21, so that's the target application or a domain. As you can see over here, the post request has been generated, which is legitimate post request, where you can see cookie replay. You have a multi-part request. This is your actual file, which can be a binary or any other file which you have posted here. And then pretty much you can go ahead and now we are going to the 100.6. That's completely a cross-domain page. And over here we have a 100.6. And as soon as we click on the page, you can see nice post request has been generated from 100.6 to 100.21. And you can see a file being uploaded over here. A nice multi-part request has been generated and sent to the server. So again, this is once you have a stream, any stream which you can inject, pretty much you can start playing around. Say for example, if you look at the view source here of the page. So what we have done over here, we have created a stream here. This is a stream of a file. So it looks like a file content which is read from your file system. We just put a boundary condition over here. We have posted a cross-domain call here. Here is a catch. We define a content type multi-part form, and then content type stream length. Over here we set, and then with credential we set to true, and then we just say, okay, send, send, send. We crafted a body and send. Now, interestingly, multi-part slash form data also bypasses your option flight request. So it doesn't have to do a pre-flight. So if a content is text plain or a multi-part, you don't have to, and there is a third content as well. You don't have to do any pre-flight check. So then you can do internal scanning, crawl for a course. If internal resources get star, then game over. Attacker can craft a page, a box behind a firewall, and then start grabbing it. Crawling with credential is not possible. So you can replay the cookie, but the content will not get loaded as such from the JavaScript. So this kind of attack vector is possible. Attacker site, you are behind the firewall, and then you are actually doing some kind of internal scanning for the course, and then you identify, okay, this is a guy where the course is set to star, so any origin can access the resource. Then you can go ahead and start accessing those resources as such. So here is a little scan which we can do as such. So we are doing just a simple scan of our internal resources here. Okay, and you can see over here it's very simple, just a call which we are making to the different IP addresses. We say, okay, open XHR connection with XHR level 2, and then look for different IP addresses which is in the 100 range. And if your content get loaded, then definitely access control allow origin is set to a star. Once you have that, essentially you can go ahead and load the HTML page as well through XHR. So over here we have just loaded the page. We say, okay, on 21 access control is set to star. You can see over here this is a key line. When you get a HTTP response back, if you have access control allow origin to star, that means that content can be accessed from any application or any domain. So then pretty much you can actually start crawling this particular application. Say for example your HR application which allows any origin to access internally, then external page can start accessing as well. Then pretty much a lot of things can be done once you have these kind of a stealth channel or a silent channel created at the back end through XHR. Once again you can set allow origin to start, so pretty much the browser will start talking back to you. How you scan and defend, so essentially look for, if you have HTML5 application created by developers, look for a content type checking on the server side, course policy scan, look for where it has been set to star, form upload with the tokens, defense and countermeasure secure libraries for streaming HTML5 and Web 2.0 content, CSRF protection, and strong course implementation. So this is a first attack vector. The second one is a click checking, core checking, and UI exploits, where the focus is on the presentation layer and some focus on a sandboxing and SOP as well. So what is a click and a core jacking? So we have this UI redressing attack vector, which is popularly known as a click jacking. It is actually hijacking clicks, tabs, events, anything from the browser. So essentially I'm clicking something, imagining something else, and then when I actually click something else will happen. So it's very complicated vector, but easy to exploit. So HTML5 and RIA has more interesting resources embedded in the browser. So you have a Flash, Silverlight, video, audio, all these different resources embedded in your HTML5 page. So when you can control everything from the DOM, you can actually change the underlying resource on the fly. Essentially, that's phenomenon is essentially known as a cross-origin resource jacking or core jacking. So first, on HTML5, one interesting thing is when you load iframe, so you have a new sandboxing mechanism in place called sandbox, and then you define the attributes you want to pass on the sandbox. So say, okay, allow same origin, allow script when you do access. So say for example you are on yahoo.com and there is an iframe which is loading a google.com within the yahoo.com, and you do a sandboxing then, and in the sandboxing you say you don't put this allow script, then Google will get loaded in your browser in iframe, but it won't allow you Google to run any JavaScript. So the first thing which was happened for the click jacking, if you look at the click jacking defense, The click checking defense is embedded in a JavaScript, which checks what is my parent domain, and it won't allow you to get loaded in your browser. That domain, that check itself is invalid now, because I can load any page, and while loading the page, I can say don't run a JavaScript, so don't run essentially a frame busting code. So that's one. On the core jacking, essentially, say for example, you have a DOM based access, and you have a flash resource on the page. So through the DOM based access, what you can do is that you can get the element of that particular resource and then change it to any other cross origin resource as such. So say for example, we can say, okay, there is a login form in a flash, so we grab that login form and change it to say evil whatever cross domain login.swf file, and then the guy who is looking at would imagine that, okay, this is a real login form, and then it'll actually do a login. So this is say for example a flash file which is loaded in a browser. Would look like you have a login.swf file there, and then you have this particular get element by name login over here, which get loaded, and then you actually change that file or change that resource to something else, and then pretty much you can do some kind of obfuscation, or you can do a double eval trick over here to inject your single quote and double quote characters and so on. So here is a very quick demo here. So say for example, you are on 100.11 domain right now, port 8080, and you are admin. You are just logging into this page. So this is a foo bank, a sample bank where you have the login. Now, if you look at the page source here and try to identify what it's doing, it's a login SWF is there, and then it is changing certain value through eval. So you have a kind of a DOM based access over here. Okay, so now you put on alert 1 and you get the DOM based access. Now you try high, for example, it will not go through because your double quotes won't get into eval. So that's where a double eval trick will come into picture. Okay, now we are on this domain, which is 100.200, for example. You can see a red line here. So only difference between that SWF file and this SWF file is just this red line. So we have that here, and now we go back to this particular domain, and we say, okay, so this is the element which we want to change to a cross domain. We say, okay, you have this particular file or src of your SWF file, change it to something which is lying on 100.200. So if we get this, as you can see, it is right now on 100.111. Now we can actually go ahead and change it to 200. So again, if we try to put this, then what is going to happen is we're going to get an error because there is a single quote there, which eval will not like it. So we say, okay, eval the eval string. So we'll pass on this eval payload, which is the first eval, which will convert this into the string, and then it'll actually do a eval. So now you can see we get the rates. We are on a 100.111 domain, but the page or the flash file which was loaded from 200. So this is a case of a core jacking. Now this can be applied to any resources which is in your browser. It can be applied to video, audio, Silverlight files, any resources which is lying on the server. So you can apply to XAP file, which is a Silverlight file. You can actually change the XAP file on the fly as well. So scan and look for a click checking defense. Look for X frame options, which is very interesting. Nowadays, all the browsers are supporting that. Better control on the cores and creating a self-aware component while loading. So say for example, you have a SWF file. Before SWF file load itself, it should check where I'm being loaded as such. So third attack vector is a typical XSS vector, which is HTML5 tag. So HTML5 has a lot of new tags, attributes, and events loaded. So you have a tags like a media, canvas, menu, embedded buttons, commands, form controls, and so on. You have new attributes which are added in a form, submit, autofocus, sandbox, manifest, and so on. And then you have a events object, which are navigate, editable, content, drag and drop APIs, and so on. So, and a push state is also interesting one. So these are some of the new tags which are added. And based on that, definitely you have a filter. You have a blacklist filter which is running on the on your server side to protect XSS. Where if these new signatures are not added, so pretty much you can have a new vectors for XSS. A lot of new signatures needs to be added. XSS can be injected from tags and events, and new attributes are available for XSS payload. So these are some of the XSS variants. One is through a video tag you can do XSS. Another is a input select text area keygen and all this, which are a new attribute called on focus. So now whenever you are getting a reflection in the input tag, pretty much you can add this new vector called on focus with autofocus, so that will run the XSS. A mathml and the inline XSS is possible with this. And then there is various different vectors out there with the form ID and so on. So pretty much nothing new in this this vector, but just the surface of possible persistent and non-persistent accesses is increased now. So definitely look for reflected and persistent XSS, and then try with HTML5 variants, which we are doing nowadays. Defense and countermeasure, have it added to your blacklist. Standard XSS protection and encoding, context sensitive would be helpful. The fourth one is web storage through JavaScript. So this is a layer where it's possible to do some kind of a web storage enumeration. So web storage is a kind of API which is added in HTML5, a new structure called interface called storage, which is added, which is pretty much there on all the browsers, I would say. So HTML5 storage API provide a local and a session storage. So there are three types of storage: local, session, and the third one was a global, which was dropped. So now there are two kind of a storage. One is a local and a session. Session hijacking, we had a HTTP only as such when we are doing the so JavaScript will not have access to your HTTP session. But if you are setting up a session based on local storage, so over here, as you can see, what a developer is doing is setting, or libraries are doing is, it is saying a local storage set item and then setting up the actual hash value, and then whenever it makes a AJAX call, it will replay this value. So when this kind of a thing is in your browser space and you get access, pretty much you can start harvesting all this information which is lying on a storage. So this is a kind of a blind enumeration you can do. You can just look for a local storage and run through the loop, whatever variables you find, dump it and send wherever you want to send. So let me show this demo here. Okay, so you are on 21. We just log in over here, and okay, so we are logged in here. Now this is the payload, or this is a kind of a quick test where you are doing a blind enumeration. So we are defining that you are running the loop, and then you are using XHR to post whatever content has been extracted to 4.8080, and on that we are running something called node.xss.js using node.js. So we are running that script, which essentially nothing but the listener for the XSS and for a delivery. So we are listening, we are starting a web server using a node.js, and then listening for the traffic to coming back, and then when we get the back, we write to the message.txt file. So this is a simple payload checking. So we start our server for a local storage extraction on port 8080, and now our IP address is 100.4. okay, and this is our local storage payload or test load. We go and start a Firebug just to check what kind of information we can extract here. Okay, we just need to take those two variables on the top, so we take all these two. Okay, and now we run here. So you can see over here on the local storage we have this particular hash which is sustained across the scope of the application. So from this page you move to any other page, the local storage will be always there. So any page where XSS, pretty much you can extract local storage. So this is where the token line, okay, Next, we move to, say, for example, search page, and a search page has XSS, for example. So here is a typical script we run, we get alert back. So now we are just pushing the load, which will blindly enumerate the entire local storage and dump back. So we are listening over here, and we are saying, okay, set up the payload script src http 160.480.80. So I get that script and then get executed. So as soon as I search, you can see the post data has been posted, and we got the same data on a message.txt as well. So this is a local storage extraction. Same thing is possible with the DOM storage as well. So you have a document object model, and interestingly, the next generation HTML5 driven or Web 2.0 driven application has a single DOM application. So when you go to the slash page, you get the entire application, and then after then your DOM will never get changed. So at the time of your authentication, or at the time when you load the page, you will get a dump of, say, a dump of 20 global variables, which is going to stay during your entire application as such. So over here, for example, a very casual use of a global variable. Over here, we have a get login, say, for example, a login routine, which take username and password and do authentication. Over here, this line, where it's a defined temp login equal to this. Now, as you can see, there is no var in front. So this becomes automatically a global variable. So now when you get XSS, you extract this variable. So you're extracting the actual username and password, because this variable is global. So very simple, you run a loop on the DOM. So entire DOM we are enumerating, and then look for a strings, and then when you get a string, you just push the string back to anywhere you want to send. So HTML5 apps running on a single DOM, having a several key global variables, objects, and array. Say, for example, an array like this would be there, and so on. You log in onto your, say, for example, you log in onto Google, or you log in onto Yahoo, or so on, and run this particular loop. You will see how many global variables and what kind of values which are set on the global variables. You will see, for example, a token set on there. You will see your email ID set on there, or so on. So if we run this little loop here, where we're looking for the object and a string, which are global, and then we say, okay, enumerate with the JSON stringify, so you can see all these different values which we are extracting from the DOM. So this is a very similar to a local storage, but it is a more or less like a vulnerable pattern of a coding over here, where we are setting up the variables, developer setting a variable, or a library setting a variable indifferently. So over here, say, for example, we log in onto this application. Before that, we just try. This is a little utility called DOM tracer, which will show us a line, or a JavaScript lines which are executed as such. So we pass on a username and password here, and then we look at this. So these are the lines which are executed in a JavaScript. So you can see over here, username and password grabbed from the field, and then it has been sent to a temp variable. So this temp variable, when you know that, okay, this application is vulnerable and you get access as a temp variable, will become your target. So you go ahead and just type alert temp. And you can see over here we have a username and password. Oh, okay, we will do the XSS here. So we get the actual string of a temp here. Now, say, for example, there is a place somewhere, there is an XSS. So now with the XSS, you go ahead and pass on this XSS over here, and you can see the actual username and password which one can extract from the DOM. So scan and look for a scanning storage. You have to avoid when you are essentially when you're putting a local storage and a web SQL, you have to very careful. Your XSS is powered 100 times more, because now the XSS, you are not actually through XSS, you are not actually accessing the session, you're actually accessing the internal logic as well. The fifth one is SQL and blind enumeration, where a attack point is essentially a DOM, your web SQL and a JavaScript. So web SQL is essentially a small database which is created in the browser, be it Chrome or so on. So they are using a web SQL or SQLite as a web SQL database, and then there are various different methods which are exposed, open database and executes SQL. through which we can access it. So over here, for example, you have, if an application is giving you a database and a transactions and so on, you can see over here the actual, you can run a select query and then extract the transactions. So say for example, you have a point where you want to do a web SQL extraction. We need a following exploit. We can have a database object. We need a table created, or a SQLite table query, and then we need a table to run our query. So here is a simple code. This particular code will actually enumerate select name from SQLite master where type is table, and then will show us what tables are created by developer on the application as such, and then we extract. So we look for the object which is database, and then we run the SQLite query against it, and then we get the first table. So the second entry, 0 entry, is a WebKit table. So we get the first entry, which is a user table. So say for example, if we run this loop, we get a DBO database SQL results, and then we just run SQL query, and we can extract this data from the server. So the first change you can see over here, for example, you have HTML HTML5 type of application. You can see over a PID equal to 1 here. Now this PID equal to 1 is a query string, which is not actually going to the server. It is just playing inside the DOM. So there is no, since your database is already loaded in the browser, so you don't have to send that particular query or a particular value back to the server. So over here, you have a database and a category and items. As you can see over here, I can run a select query over here, and there are 7 values here. Now if I go over here, and this is how the table has been created by the app, and this is offline, so it can be available on the offline as well. And now say for example, instead of a 1, we can go ahead and do a kind of a web SQL injection. Let's say okay, SQL injection on the client side. We say okay, or1 equal to 1. So instead of looking at the first product, we can actually enumerate the entire table over here, as you can see. So that is the web SQL. The 6th attack vector is web messaging and a web worker injection. This is also an interesting one. So web messaging is a web messaging and a web worker where your application wants to talk with the inner frame, or your application wants to talk to the page which is already loaded in your DOM. So this is essentially where 2 iframes want to talk to one another, or an iframe or your main domain wants to talk with your web worker. So that's where web messaging came into picture, which is called a post message. And again, whatever new data comes will get loaded with the inner HTML or eval tag. So web worker are quite an interesting hack possible with the web worker. So web worker is nothing but like a thread which you are spinning in your browser. So then you no need to do a set timeout or set interval or so on, and it is totally asynchronous. So what you are doing is you are initializing a worker, which is say okay, new worker task.js. So that's a process, that's a script which is running in your background, and then that whenever you want to talk with that particular script, you say okay, worker.postMessage. Now when you're talking with that script, if you are not passing, if your script is not checking the origin, is not checking that okay, this call is coming from which origin, then pretty much your origin is set to star. So you're listening to everyone. So pretty much I can load that page into some funky domain and then start listening or start talking with your script. So this is where a web worker would come into picture. So web worker is a new spec which is integrated in your HTML5. So you have a web page with a current DOM, and then you have a web worker, which is XHR, location, navigation, and so on. And then you have pretty much you don't have access to the parent. So this is a trick. So you can't access, say, being the web worker, I can say, well, okay, give me access to the parent DOM. But definitely the page would have access to the lower DOM. So some typical issues would be it allow XHR, so you can do a cross-domain issues. And one of the more important one is it allows you to a DOM-based access as well, because you are not validating the content which is coming from the web worker. So say for example, let me quickly show this demo. Okay, so here is a web messaging. a little web messaging system which you have started, which say, okay, it's a chat message or a web messaging. Show me a last message, for example. So this is a web worker thread which is running at the background. And when you click on the message, you get accessed because over here you can see a web worker has been created. This is the one. There are two commands which are put in place, a read and a stop, and then web message, which is a background script running, and whatever it send you back, you are loading without validation to a inner HTML. So when you're loading into inner HTML, someone can actually go ahead and give you the script as well. So that's on a web worker. So pretty much you can have a set of different hacks on a web worker. Again, a JavaScript scanning is required to validate your web worker. The A7 is essentially a DOM-based XSS, which is again powered by HTML5 over here. So you have a DOM level 3 over here. So pretty much you can, it's a pretty enhanced DOM which we have. And a root cause is essentially a DOM is already loaded. You have evals, you have a JSON padding, and so on. So there are tons of different mechanisms by which a DOM-based XSS can happen. And then you have Ajax function, which is doing a dynamic eval where the DOM can be injected with the content. So this is an interesting vector where you need to check for the DOM calls, you need to check for the evals, and so on, and then you have to use a secure JavaScript coding. The eighth one is a caching offline. So when you load the HTML application, you can define something called manifest, and then you define app-cache.manifest file in which you say, okay, these are the offline pages. So load the offline pages, and whenever user asks, don't come back to me, but load from your cache only. So this is a poisoning is possible. You are in a cyber cafe or somewhere where this cache has been already loaded. So when you go actually to the yahoo.com, Yahoo JS will not run, but your JS will actually run. So that extended to HTML5 widgets and so on. So again, if a widgets are not running in a properly sandboxed environment, then one widget can actually listen to the other widgets on HTML5 tunnels or a web messaging. The ninth one is a WebSocket. So WebSocket is essentially you get a very powerful full duplex TCP channel from your browser via WebSocket. It opens up back doors for the browser shell. Quick port scanning is possible. Botnet and so on can leverage. So this is just started. So WebSocket has just came up. We'll see how WebSockets get implemented, what kind of libraries which we get out. So pretty much you can quickly run a script and do a internal scanning or so on. And the final one is a bunch of different new APIs out there, which is a custom protocols. You can define a custom protocol. We have say mail to protocol. You can define a mail to protocol customized to the URL and so on. So other APIs which are coming is a file API, drag and drop APIs, and so on. So a lot of different stack around which one can craft and attack vectors. So say for example, let me show this this sustained XSS one. So usually we have a persistent and non-persistent XSS. So say for example your search page is XSS. As soon as you move from a search page to someone else, your XSS execution will stop. But with HTML5 you can craft a page which give you a sticky XSS or a sustained XSS. So over here, say for example you have XSS page, and now over here this is a kind of a payload which you are setting up. Again, you have this node XSS which is doing a listening over here, and this watch payload. Now over here you are loading a same domain in the iframe, and then on the sandbox you are saying the same origin as well. So over here you have a 100.21 where you found XSS, so you're setting up the URL 100.21, and here is your iframe which name is ifu1, and over here you can see we have the URL send, and then we are saying allow same origin, allows and allow script here. And then bottom line, on the bottom what we are doing is leveraging Windows history.pushState. So we can actually control the address bar. We say, okay, whatever has been clicked in the iframe, change the address bar to that particular value, and then pretty much you are in control of whatever is being done in the iframe. So you say, okay, loop through all the inputs, and at every second give me the report back that what input has been injected on 100.6 port 8080. So essentially what we are doing is on the XSS page, we are loading our payload and then we are keeping an eye on the guy. So the XSS payload will remain till the guy is browsing on that particular page. So over here, say for example, this is a search page. And now over here, we go ahead and, okay, we are now listening on this. And now we are passing up the payload here. So now you are actually looking at the page, but this is a iframe on top of your page. So you are already iframed, and the backend code is actually watching you what you are doing on the front. And now interestingly, when you click any of this link, so now whichever page you go, all first two inputs on the HTML page is being watched over here, text 1 and text 2. And now say for example, I go to say login page. Now as you can see, a login page, even though you're in an iframe, you clicked this and your address bar has been changed as well. So interestingly, now you have the watch on this particular page. Now whatever you do on this page will be monitored by the XSS. So over here, for example, we have our two text boxes which we have set on this. So user and password, for example. Any first two right now, we can loop through infinite. We say, okay, as soon as we type foo, you can see a foo has been sent to the 100.6 domain. Now we type something else on the password field, foo bar, and it is also has been sent. So pretty much you have created a sustained XSS channel between the frame, and essentially a sandboxing which you can leverage, and then you can leverage a push state as well. So that's pretty much a walkthrough on the HTML5 top 10 stack. This is just the warming up. I would say this is like what we are looking at right now is just a 5 or 10% of HTML5. In next 1 or 2 years down the line, we'll get all the specs which are under working. File API would be interesting, which allows you to do some kind of a file manipulation and so on. So pretty much we are getting out from Silverlight and Adobe and so on, and we are pretty much entering into HTML5. And interestingly, HTML5 works seamlessly with the mobile devices. So pretty much you have HTML5 application, it works on any mobile device as well. So that's pretty much it from my side. Thank you very much for listening me patiently, and pretty much I don't have time for questions, but you can come down and have questions if you want. Thank you very much.